Welcome to the Deep Dive. Today we're looking at a book that really shook things up. And it didn't just warn people, it fundamentally changed how we look at our role on the planet.
We are, yeah. We're diving into Rachel Carson's Silent Spring. And it wasn't just, a dry science book. It was a powerful wake-up call. She managed to translate these really complex ecological dangers into something anyone could grasp.
And our source material is straight from the book itself. We've got excerpts, so we can really hear Carson's own voice and see the evidence she laid out all those years ago.
Right. And our goal here, our mission, if you like, is to pull out the core insights from this work. What was her main message? What evidence did she actually use? And crucially, why does it still matter so much for you, the listener, today?
Because, yeah, get ready. This book didn't just make waves, it landed like a bomb. Huge bestseller, won awards. But it also kicked off this immediate, really furious backlash from some very powerful industries. So, okay, right at the beginning, Carson really focuses on a central problem. What was that main issue she was pointing to?
Well, she highlighted the sudden, just unprecedented scale of synthetic chemicals being released. Released everywhere. Before that, maybe people used mineral stuff like arsenic or things from plants, nicotine maybe. But after World War II, it just exploded. Everything changed.
And the sources really hammer home the scale of it. We're talking hundreds of new chemicals being invented, like every single year.
Yeah, hundreds, leading to billions of pounds of this stuff being made and spread around. Billions, exactly. And Carson argued pretty forcefully that calling them just insecticides, like they only kill insects, was totally wrong. She actually preferred the term biocides.
Biocides,
yeah.
Because they kill, well, broadly, life.
Life, exactly. It's in the name. Their impact was much wider.
You mentioned that shift after World War II. The sources point to a really interesting origin for this whole chemical boom, don't they? Back to wartime research.
Yeah, chemical warfare programs specifically. It's kind of chilling, actually. They were apparently using insects to test how toxic chemicals were for humans.
So the goal was toxicity, potency.
Yep. The purpose was potency. And Carson shows the key difference with these new synthetic chemicals wasn't just the amount, but their enormous biological potency, as she put it. Unlike the older, simpler stuff, these new chemicals actively messed with basic, vital processes inside living things, sometimes in really complicated ways.
Okay, so you got these super potent chemicals made in massive amounts. What happens when they actually get out there into the environment?
Well, that's the thing. They don't just vanish or stay where you put them. They have this incredible reach. They spread, and the sources give some, frankly, alarming examples of how they move around and, maybe more importantly, how long they stick around.
Yeah, I saw those numbers. Aldrin and dieldrin staying in the soil for 4 years or more, toxaphene for 10 years, chlordane 12. That's not temporary.
No, not at all. And from the soil, they wash into rivers, streams. They get into the groundwater that people rely on.
But the real kicker, the danger Carson really documented so carefully, was the accumulation, right? How they build up inside living things.
Build up and get more concentrated as you go up the food chain. It's called biomagnification.
Biomagnification, okay.
And the Clear Lake example she uses is just the classic, really stark illustration of this. They used a chemical called BDD at what seemed like a low concentration to control gnats in this lake.
Okay.
But then tiny organisms absorbed it, and suddenly it goes from almost nothing in the water to 5 parts per million ppm in the plankton.
5 parts per million. That sounds like a lot already.
But it gets worse. The fish eating that plankton, they ended up with 1,600 ppm.
Whoa.
And then the grebes, these water birds eating those fish, they measured a staggering 2,000 ppm in their tissues.
2,000.
2,000. And the result, the grebes on that lake were almost completely wiped out.
So hang on. If the birds eating the fish are dying, it makes you immediately wonder, what about people eating fish from water like that?
Exactly the question. And maybe the most unsettling thing Carson revealed was that these chemicals weren't just in Clear Lake or sprayed fields anymore. They were basically everywhere, found in the bodies of most humans, detected in mother's milk, potentially even passed to unborn babies. It just became this global, inescapable presence.
Which leads us right into the price nature paid. Especially the wildlife impact that gave the book its title, that really haunting phrase, and no birds sing.
Yeah, Carson drew a very direct line between all this chemical spraying and sharp declines in bird populations. And it wasn't always, dramatic poisoning where birds just dropped dead instantly.
Right.
Often it was slower, the chemical moving up the food chain, building up silently.
That elm leaf earthworm robin cycle she described feels like such a perfect tragic example of that, doesn't it? Spray the elm trees for beetles.
Mm-hmm.
Poison gets on the leaves. Leaves fall. Earthworms eat the leaves, concentrating the poison.
And then the robins eat the worms and get a lethal dose. It just shows how linked everything is. You can't just affect one thing. And the sources give these really heartbreaking specific examples. Mass bird deaths in Detroit where spray drifted. Hundreds found dead in Blue Island, Illinois. Bird populations virtually wiped out, they said, in Joliet after they sprayed for Japanese beetles.
That Sheldon, Illinois story is particularly bad, isn't it? The sheer amount of chemical they used. Dieldrin, equivalent to like 150 pounds of DDT per acre. That's insane.
It's an incredible concentration, and biologists there actually saw the poison attracting birds to the dying beetle grubs. It was like baiting them, mass casualties. And then they struggled to get funding or cooperation from agricultural officials to even study it properly.
So depressing. And the victims were common birds we see all the time. Robins, thrushes, quail.
Songbirds, yeah. Woodcocks, quail. Although, interestingly, she notes house sparrows seemed tougher, more resistant in some places.
And it wasn't just birds, was it? The book mentions dead rabbits, muskrats, opossums, fish found after spraying too.
Right, and mammals, like raccoons or moles, they'd get it indirectly too by eating contaminated earthworms and things. And then predators, hawks and owls, eating poisoned prey higher up the chain. It ripples outwards.
There are even reports from farmers, a vet named Dr. Poitevent, talking about livestock, cattle, hogs, poultry dying or failing to reproduce after these treatments.
Yes, although, according to Carson's sources, the Department of Agriculture at the time basically denied these animal losses were connected to the pesticides.
Okay, so we've seen the direct hits on wildlife. But Carson also talked about a deeper issue, right? An ecological backlash. What does she mean by that?
Well, she argued that when you spray these broad chemicals, you don't just kill the pest you're aiming for, you also kill its natural enemies, the predators, the parasites, the things that normally keep that pest population under control.
Ah, right. So you're essentially knocking out nature's own pest control system.
Exactly. You're disrupting the built-in checks and balances. And the consequence, often, is what they call a flare-back or resurgence. The target insect comes back, but now its enemies are gone, so its numbers just explode.
More numerous than before the spraying even started.
Sometimes, yeah. The source mentioned black flies ending up 17 times more abundant after spraying in one case, or huge outbreaks of cabbage aphids.
Wow. And then there's the secondary pest issue, where something that wasn't a problem suddenly becomes one.
Precisely, because the broad spraying killed its natural enemies too. The spider mite is the classic example Carson used. DDT killed off the things that ate spider mites, and suddenly this tiny creature becomes a major worldwide pest, damaging crops, browning trees like Douglas firs.
And this happened in farming, too.
Oh, yeah. Sugarcane borers increased in Louisiana after they sprayed for fire ants because the spray killed the borers' enemies. Corn borers increased in Illinois after Japanese beetle spraying, which basically undid years of expensive biological control work they'd already done. It's counterproductive.
Which leads to this really critical idea she called the rumblings of an avalanche, insect resistance.
Yes, it's basically evolution sped up. Darwinism on fast forward. You spray, most insects die, but the few naturally tougher ones survive. They breed. Their offspring inherit that toughness.
And the terrifying thing here is that it creates this endless spiral, right? You need stronger, deadlier chemicals to kill the resistant bugs.
Which just selects for even tougher bugs. So as the book says, it's a chemical war that's never won. You're always chasing the next resistant generation.
And the numbers she cited were already alarming back then. Like before 1945, maybe a dozen resistant species known. By 1960, 137.
Yeah, 137. And the World Health Organization itself is calling it a major global problem by then.
And other weird side effects, too, like snails surviving the insecticide.
Right. Snails often aren't much affected by insecticides. But snails can carry nasty parasites, things like blood flukes that cause schistosomiasis in people, or liver flukes that devastate livestock and cost farmers millions. So kill the insects, maybe help the snails and the diseases they carry proliferate. It's complex.
We've covered the impact on nature. Let's shift now to what the book presents as, well, the most direct concern for us, the human price. Carson says pretty bluntly that every single person is exposed to these chemicals basically from conception onwards.
Yeah. And while, acute poisoning happens, farmers, spray operators getting obviously sick right away, which is terrible, The bigger concern Carson raised was the cumulative effect, the slow, delayed impact of absorbing small amounts over your whole life.
Because it's not immediate, it's easier to ignore or dismiss.
Exactly, it's insidious. But the sources detail some really worrying potential physiological effects. Liver damage, for instance. The liver is key in detoxifying poisons, so damaging it weakens your defenses. She even suggested a possible link to rising rates of hepatitis and cirrhosis back then.
And nervous system effects, too.
Things like tingling, tremors, even convulsions linked to DDT exposure. And another class of pesticides, the organic phosphates, work by disrupting vital nerve enzymes.
And you mentioned earlier they can interact, like one chemical making another one worse.
Yes, that's a critical point often missed. Chemical cocktails can be way more dangerous than any single ingredient on its own, even if they seem harmless individually.
Then there's the cancer connection, a whole chapter titled 1 in Every 4. That's stark. She mentioned warnings about cancer risks from contaminated drinking water.
She did, citing studies from places like Holland and historical cases involving arsenic in water supplies. And she specifically highlighted the work of doctors like Malcolm Hargraves, who was finding links between pesticide exposure and blood disorders, things like leukemia.
Using specific cases from the sources too, right? Farmers, students, people with real exposure histories.
Yes, real people's stories. And it wasn't just the active ingredient either. The book points out that commercial pesticides are mixtures. The solvents, the other stuff in the can, could also be harmful.
So the overall picture she painted was of us living in, what was the phrase, a sea of carcinogens.
Yeah, a sea of carcinogens. Her argument was that these man-made chemicals were a totally new kind of hazard. Life hadn't had millennia to evolve defenses against them, unlike some natural carcinogens that have always been around. She used that epidemic of liver cancer in hatchery trout as a really serious warning.
Like a canary in the coal mine for introducing potent cancer-causing agents into any species environment.
Exactly, and she made this powerful point. Unlike, say, infectious diseases where maybe our role in spreading germs was unwitting, humans deliberately put most of these chemical carcinogens into the environment.
Which
means, she argued, we can choose to remove many of them. We have agency here. But Carson didn't just paint this dark picture. Crucially, she also showed there was another way. She called it the other road.
the alternative path, right? Not about destruction, but about preservation, working with nature, using biotic controls. What exactly does that involve?
Well, basically, it means using biological solutions, understanding how living things interact, the whole fabric of life, and using that knowledge to manage pests instead of just blasting everything with chemicals.
And some of the examples she gave are really clever, almost ingenious compared to just spraying.
They really are, like turning a species' own biology against it. Dr. Knipling's technique with the screwworm fly, raising sterile males, releasing them. So the wild females mated but produced no offspring. It was brilliantly successful, wiped out the pest in huge areas.
That's amazing. And using diseases, too, but specific ones.
Yeah, diseases that target only the pest, like milky disease for Japanese beetle grubs. Or this bacterium, Bacillus thuringiensis Bt, which produces a toxin that kills certain insect larvae but is harmless to other things. Viruses for specific caterpillars. The key idea was precision, targeting the pest without harming everything else.
And there was an alternative for weed control, too. Selective spraying.
Right. Dr. Frank Egler's approach. Instead of just nuking all the vegetation along roadsides or power lines, you selectively target just the tall, woody plants you don't want. You leave the beneficial shrubs, the wildflowers. It protects habitat.
And probably uses way less chemical.
Way less chemical. And he argued it was often cheaper in the long run because the established low-growth plants help keep the unwanted tall stuff out naturally.
But the sources say there were big obstacles to these kinds of approaches getting traction, didn't they?
Absolutely. A major institutional bias, especially in universities and government research labs. The funding, often influenced by the chemical industry, flowed heavily towards chemical research.
So not many scientists were working on these biological alternatives.
Very few, comparatively. The sources mention maybe only a small percentage of entomologists were focused on biological controls. There just wasn't the same kind of money or career path in it.
Which led to people like A.D. Pickett, arguing that you can't solve a biological problem purely with chemistry?
Exactly. Pickett and others were saying, look, pest control is fundamentally biological. You need biological understanding and biological tools, not just reaching for a deadlier spray nozzle every time things get tough. Pickett's own work in Nova Scotia apple orchards, using integrated control, carefully combining different methods, minimizing sprays, was held up as a prime example that this other road could work.
So wrapping up, what's the final choice Carson presents us with? It feels very clear-cut in the book.
It really is. She lays out two paths. One is the deceptively easy road of just relying on more and more chemicals, which she argues leads towards ecological disaster. The other is the less traveled road, the one that requires more thought, more understanding, but works with nature for preservation and genuine long-term balance.
And she anchors this choice in a really powerful idea about rights and obligations, doesn't she?
She does. She asserts that because we have this obligation to endure, to survive on this planet, we therefore also have a fundamental right to know. A right to know the full facts about the risks these chemicals pose, the risks we're being asked to accept.
And that knowledge isn't just abstract. For you, listening now, understanding this history, this evidence, it empowers you, doesn't it? To actually take part in the ongoing decisions about which path we take.
Right, to not just passively accept the tranquilizing pills of half-truth, as she memorably put it, to demand better.
And ultimately, the book really stresses prevention, doesn't it? That's stopping exposure, especially getting carcinogens out of our food, our water, our air in the first place. That's smarter and more humane than just trying to cure the diseases later.
Far more effective, especially when you think about protecting future generations. It's about tackling the problem at its source.
So just think about that for a moment. The sheer scale of chemical use Carson was describing decades ago and the impacts she documented in Silent Spring. What does reflecting on that history tell us about the challenges we still face today, trying to balance, human progress with the health of the planet that actually supports us, all of us?
Yeah, and maybe ask yourself, in a world with new environmental challenges constantly emerging, what does that right to know that Carson fought for actually mean for you today? How do we ensure we have the information we need to make wise choices moving forward? It really underscores how vital understanding these connections in nature is, and how crucial transparency about the impacts of our actions remains. The choices she highlighted back then, they feel perhaps even more urgent now.